Hello, everyone, and welcome to my talk on how Vonage moved its client SDKs to Kotlin Multiplatform and save the world, kind of. So before I get started, I would like to kind of go through a couple of introductions. So first and foremost, I'd definitely like to introduce a gentleman called Ashley. He's a software developer engineer on the engineering team that did the move to Kotlin Multiplatform. He's also someone that's been with the company for quite a few years, had a wealth of knowledge around the history of our SDKs, around how things were done before, the different attempts at code share and all those sorts of things. So I definitely picked his brains for countless hours to flesh out this talk, and I definitely want to thank him for that. He is now also on Twitter. He's very proud of the fact that he has finally come to social media. So do check out him on Twitter as well. I'm sure he'd absolutely love to talk about Kotlin Multiplatform with you all day long. So do check him out. And the second person that I should introduce is myself. So I've been an Android developer since 2009. I more recently moved into developer relations and was a Android developer advocate with Vonage. I have now turned to the dark side and taken a position as a manager, but I manage the client SDK team. So I now cover Android, iOS, and JavaScript. And you can go follow me over on Mastodon, on the Android dev.social server, or anywhere else really around the internet under Dev with Zachary. So it should be quite easy to find me if you do want to do that. So before we really get started, let's think about a couple of takeaways that I hope you'll be able to have from this talk. Unfortunately, those don't involve pizza, but they should still be quite good nonetheless. So first off, I do want to start by saying this isn't a code talk. This isn't a talk about coding with Kotlin Multiplatform, how we, the actual nitty gritty of implementing it. There's lots of really great talks that already exist in this space. Some really great talks already on this conference about Kotlin and Kotlin Multiplatform. So what I wanted to do is something a little bit different, which I hope will be just as interesting and hopefully quite insightful. And I want to kind of take you through a real world example of an engineering team that built a library in Kotlin Multiplatform. Some of kind of going through and learning some of the pain that comes with that. I will go through the history of our SDKs, so hopefully you can kind of understand where we were coming from and why we wanted to make this happen. And also kind of touch on a few of the different past attempts at code share that we've had. Like we've sort of said, a lot of different people have tried different ways of sharing code across different platforms. And we certainly have as well. So it's definitely worth looking at those to get a good understanding of where we are today. And hopefully if we can take those pains that we've learned from, and hopefully you can learn from, you can actually then see some of the success as well. I love this meme. I think this really sums up being a programmer. Some days you can feel like the most amazing job, the most amazing person creating really cool things, creating new universes. Other days you can feel like you know nothing at all. So I thought that was quite a good way to sum that up. But what I want to touch on is kind of how the differences manifested themselves between our old code share and Kotlin Multiplatform. What the SDKs actually do look like now, which hopefully can kind of give you some more insights into what you might want to do with your own libraries or just how to use those libraries. But more importantly, some of the surprise improvements that we've seen, some of the things that we didn't necessarily consider that aren't necessarily related to actually writing code within Kotlin Multiplatform, but have improved our processes and everything else along the way. So if we're going to be talking about these things, we're going to be talking about Vonage SDKs. What are Vonage client SDKs? What do I mean by that? Well, Vonage does a range of APIs. We do communication APIs. So we do things like voice, video, SMS, and then other APIs built on top of those things like two-factor authentication and that sort of thing. And we have a range of SDKs on a range of different platforms. We have them generally split into two sections. We have server SDKs, which are things like Python, PHP, .NET, Java, stuff that you would be running on a server. And then we have client SDKs, things that you would be running on your clients. So our main focus there is Android, iOS, and JavaScript. And I think one of the key points as well, and one of the reasons why this kind of move into Kotlin Multiplatform was so successful, was that really our SDKs are quite simplistic. And that, I think that's a good thing. Essentially, they are just wrappers for the different APIs that we offer. So our APIs are all REST APIs. They use WebRTC for things like video and voice. So all they're actually doing is wrapping that and encasing that, with the goal to make it as easy as possible to use those APIs in a native kind of way that you would expect to use on your different platforms. And obviously that's slightly different between Android, iOS, and JavaScript. How you expect to do things isn't necessarily all the same. But I'm in developer relations, and we consider developers to be our world. We consider that to be the most important thing, and trying to make sure that this is as friendly and easy a process for you as it can be. So that's what we mean by client SDKs in the context of Vonage and the products that we offer. So with that in mind, I'd like to take you on a short history lesson. So a long time ago, in a tech company far, far away, there was a small European startup, which you may have heard of, called Nexmo. And Nexmo had 3 separate native SDKs for its clients. It had an Android SDK, it had an iOS SDK, and it had a JavaScript SDK. These were all managed by separate teams, were completely separate in all respects, other than the fact that they were encapsulating the same APIs. So they were individual wrappers for the same APIs, but on the different platforms. And I think especially when asking Ashley and when asking the rest of the team and looking back, the biggest issue that they had with that was that it was incredibly tough to test across all platforms. Whenever there was a new feature for an API or a brand new API or anything like that, that feature had to be written into the SDKs 3 separate times. And obviously that meant that essentially there was 3 times the work to implement something new. And it wasn't just that there was 3 times the work, there's 3 separate people working on it. Because there was 3 separate people, the way the thing was being implemented was going to be slightly different each time. Now, even with the most perfect, solid design spec, perfect, solid specification of what needed to happen, people are always going to interpret that differently. And when you've got different people on different teams interpreting the same thing, there leaves a lot of room for, personal kind of preference. And at the start, that's fine. That's a very small thing. But that over time grows into something quite big. And what you end up with is 3 SDKs that are completely different in many respects. They do the same thing, but different in different ways. And that makes things like testing and stuff very difficult. You have to write separate tests. You have to have, localized knowledge for each one of those SDKs. And it also makes it difficult for developers, because quite a few developers, that use those SDKs probably actually use multiple platforms. They might be building an Android and an iOS app, or maybe they have a web version of their app. And so it's kind of quite counterintuitive if you've learned how to use one SDK and now you have to use a different one and you realize that they're different. So there was lots of kind of friction there, which we really didn't like. And at that time, Nexmo was purchased by Vonage. So Nexmo became successful enough that someone wanted to buy them, and that someone was Vonage. And so Nexmo became Vonage's API platform. And then eventually it became that they were Vonage's APIs. So At this point, it's quite a big change for the startup, obviously. You're being merged into another company. There's a chance to do something big and different. And that was the time to do an SDK rewrite. That was the perfect time to do this. And so we did. And one of the first things we actually looked at, and we're talking about 2018 here for an idea of the timeline, they looked at Kotlin Multiplatform. The JavaScript team were actually very interested in this brand new, a very alpha thing that was coming out. And they were interested in giving it a go, seeing if we could use this for code share. Now, one of the big issues that they faced is they wanted to do everything in Kotlin Multiplatform. They wanted to completely rewrite all 3 SDKs, no native code at all, everything within Kotlin. And as you can imagine, at that time, this failed. That wasn't really a possibility. It also, obviously, at the time, multi-platform just wasn't there yet. There was holes in the gaps in the functionality. It wasn't going to work for all 3 platforms as well as it could. We would like, and lots of other reasons. But fundamentally, the biggest reason was the fact that they wanted to do everything in it. So that wasn't going to work. But we did still want code share. We did still need to do something to improve the situation. So enter C++. At the time, I mean, it allowed for code share. Every platform had an implementation that would work well enough, and it was a much more seasoned language, a much more seasoned offering for doing things like this. And essentially what it was decided is you'd have a base level with base level in C++ that would handle some stuff, and then platform specific code would be written on top of that to hopefully alleviate a lot of the issues that we were having and build a common ground for all platforms. Happy code share, right? That's perfect. That's exactly what we set out to do. C++ has been around forever. It works. It's great. No problems there. We can pack our bags and be done. No, actually, it didn't work out that way. So what actually happened is we ended up in a situation much like this diagram. We had a thin layer of C++ code, but the bulk of the code bases was still in the native languages. So, I mean, it doesn't take a mathematician to realize that actually what we've done here is add a new language, not reduce the amount of different languages. So instead of now having 3 separate SDKs, we had 3 separate SDKs with a 4th abstraction layer, which just made things even more complicated. One of the big reasons why it made it more complicated was the fact that the C++ code wasn't accessible to everyone on the team. Originally, the teams were siloed Android developers, iOS developers, JavaScript developers. Some of those team members probably had some C++ experience from previous lives, but there was no definitive kind of knowledge shared across the teams, and therefore kind of very specific people in each team had to do that part of the work. And that really limited the release cadences that we could follow. When you're building a library, it's really important to be quite reactive. If there's a bug found, or there's a new feature in one of the APIs, you want to be able to implement that, fix it, ship it out as quick as possible. You can't do that if you're relying on a few core people to be able to actually touch the C++ code. So after much kind of begrudging and dragging of feet and sighing, it was agreed that we had to rewrite again. It wasn't going to work. It wasn't sustainable. So fast forwarding now to sort of 2021, and it's finally agreed that that does need to happen and we get buy-in. But to what? What is that going to look like? Well, we still want to continue with the code share. We still want to continue with that beginning goal. But how do we do it in a way that's quite sustainable and is actually going to work for the teams that we had? Shared code, just better, simple, problem solved. Well, in reality, what we wanted to actually do is something more like this diagram, where a decent chunk of the code base is shared. And when it's necessary or when it's smart to actually have native code, we allow that to happen. We don't try and shoehorn everything into shared code, but we also kind of are quite pragmatic about what is and isn't in there. And the general goal, the general rule that everyone came to was share the business logic, leave the low-level platform stuff to each platform. So all the main business logic, all the processing of those APIs, of the different kind of fields that are going to be in them, the responses, everything that you expect with a like a RESTful API, let that happen in code share, and then where you need it, you can use platform specific if necessary. So, okay, we've got a design for our general library, our general structure. What options were actually available to make that happen? And that wasn't just what options are available in general in the market. I think if you go down that rabbit hole, there are lots of options. But more importantly, what options were available where we already had some shared knowledge on them, where we already had kind of some motivation to use them. And really, the team came up with three options. Either we stick with C++ and just rewrite it, or we have a look at Rust, or we have a look at Kotlin, Kotlin Multiplatform. So first up, presented to the team was C++. Do we take the C++ and just rewrite it, put the business logic in there, and be happy with it? And the team kind of came back with a resounding no, please, no, never again. No one wanted to touch it. No one wanted to do that. It was going to be too much work, and it was too clunky as it was. So no, we're not going to go down the C++ route. So that left us with the two options. We could go with Rust. Now, with the thing at the time was with Rust, it was very powerful. It was quite new as well. It was exciting. It was different. Lots of people were jumping on it. It was really great for sharing code. It was a good option. There was some issues around kind of binding between the Rust code and the native platform code, which the team kind of highlighted as possible issues. And they also weren't so sure around some of the tooling that was available and kind of the general process of developing code share in Rust and then having it across those three platforms. It was a bit more of an unknown for the team, and unknowns are scary. It's hard to see that as a good option when, you're scared of what's going to come. So there was the other option, which some of the team already had some experience with from previous attempts at using it. And, obviously the Android team were quite happy you could use Kotlin. They understood the language. So Kotlin Multiplatform made quite a lot of sense for the resource that we had to give that a go. It was also at this point much further developed, much more, I hesitate to use the word mature, but much more developed than it was previously. And of course, it was also a lot easier to interact with the Kotlin code in backwards and forwards with native code. So it was decided that we will prototype this and give it a go. We'll take a couple of our APIs and we'll try to implement an SDK for those. So it was time to prototype. It was December 2021. And as we all know, December is a time that no one wants to do any actual work. People are quite happy to get their heads down and kind of do as little as possible as they wait for the holidays. So the team decided to kind of hide away and build this prototype over the course of December. One of the things that they made sure to do, learning from the first attempts, was to make sure that they were very careful about what did and didn't go into CodeShare. It was specifically going to be Kotlin Multiplatform was just for business logic. Platform-specific code stays out. And what do I mean by platform-specific code? Well, one of the big things for that is going to be, for us, was the networking layer. We already had very good HTTP, WebSocket, WebRTC clients that were either developed in-house or were using libraries that we already knew for different platforms. We already had that layer kind of quite well established. So it kind of made sense to keep that and use that for this. We could expose that platform-specific code behind interfaces. Kotlin Multiplatform can use it and stick to the business logic. So that was kind of the main goal there. And, this is one of the benefits of our SDK being quite simplistic in nature. It didn't need to do any heavy lifting on the platform-specific side. There wasn't much else going on other than networking. So through December and then into January, the prototype was completed and it worked. It was a viable option. At that point, we started to be able to get product managers, kind of engagement, people within the company buying into this idea that, yeah, actually, it would be good to do a new SDK and this would work. But as with all good stories, there came some drama. It was a new year and a few things happened. For one, Ashley dared to have a baby. He went on to paternity leave and disappeared. He was such a big driving force to get it to this point that caused things to kind of slow down quite significantly. I will, of course, say congratulations, and him having a baby is a very good thing, and I'm very happy for it. But in terms of this project, it slowed things down. Then, as with, all companies, people leave. Things had already started to slow down because there was less of a driving force. And combine that with a couple of people leaving the team, which meant there was less resource for the team to continue pushing this forward. There was less resource. People were spread a bit thinner. And the team had to focus on bug fixing. We still had current SDKs that we had to maintain, that had to continue to work. People were using them in production environments. We couldn't just abandon them to focus on a new SDK. So the resource that was available, unfortunately, had to be diverted towards that. And again, that really started to slow things down. I think for a while there, it started to feel like maybe this wasn't going to happen. And we were all stuck with what we had. But wait. Through doing that, the team was reminded of a lot of the pain points, a lot of the issues with the old SDK. They understood that actually this really doesn't work very well and something needs to be done about it. And just like magic, just at the right time, Ashley returned to triumphant fanfare, I'm sure. And the team were like, look, we really don't like having to support this old SDK. We really want to do something new. We want to make this better. How do we do that? And Ashley, who is, a very wise person, he said, sod it. Let's do it. And with that, we moved from prototype into SDK. But what actually needed to happen, there was still work that had to be happening. It wasn't just going to magic itself into a full SDK. One of the key things that was kind of really highlighted was the fact that up until that point for the prototype, iOS and Android were the only things that had been focused on. JavaScript hadn't actually had any kind of checking yet. So the team had to spend quite a lot of resource to actually look at that and make sure that that was going to be viable. There's no point in having all this set up and then that not work. So that was kind of a big moment of, oh, actually, yeah, we need to do this first. They did that. And then I asked, well, and they did that and that was proven successful and they moved forward. So I asked the team, what were the main changes? What was the difference between building this new SDK and building the old SDK or updating the old SDK? What really stuck out to them? And not from a syntax point of view, not from a language point of view, but just high level. What was the differences? And I guess the first one's kind of obvious, but it's worth saying. The team had to learn Kotlin. At this point, the team had kind of come together. So it was one client SDK team, but it was a mix of Android, iOS, and JavaScript devs. Many of those didn't have Kotlin knowledge. Obviously, I mean, Android developers were over the moon. They had an easy life. But the others needed to work and needed to learn this new language. So it's kind of important to consider that if you're going to go all in on something like this, your team is probably going to have members of it that need extra support and help to raise their skill level and learn the new thing. And it's not just the language that they had to learn, it was the build system as well. Again, Android developers were sitting back, sipping pina coladas and very happy with themselves because they didn't have to learn much of new things. But I think iOS developers were quite sad. I'm sure they were kind of crying in the background saying, give us back our make files. But in the end, everyone had to get all in on Gradle. It's the only realistic way to go. So again, it was something new that people had to learn, and that takes time, that takes effort, and you have to be aware of that. And then the other thing as well, which I think was, for me at least, was a little bit more surprising because I didn't really consider it as an Android developer. But of course, there was a shift in tooling as well. People had to start using Android Studio, or at least an IntelliJ IDE. And that wasn't such a huge issue for the iOS developers. They were used to Xcode. There's kind of enough similarities that it makes sense. But where it really hit home was the JavaScript developers, who were kind of used to being able to use whatever they wanted. But also those developers that were actually working on the C++. Some of those developers were actually still just using Vim in the command line. They didn't have anything more than a text editor. They didn't need anything more than a text editor. So there was quite a lot of transition there in learning. And I would definitely not recommend using one of the developers' computers from those teams, because I know a lot of them have weird and wonderful keyboard shortcut mappings in Android Studio, because they're so used to other things that they've kind of remapped it. And that's quite a scary situation if you try and sit down on their computer. But it was another thing that really needed consideration. And then, where are we today? Well, we are where we are, and the Vonage Client SDK for voice has been released. Another key thing that changed through this design process was splitting out our SDK into a more modular nature. So we have a voice component, we have a chat component, then we have a separate video SDK. But the point here being, if you just want to use the chat component, you don't have to use the voice or video, which has WebRTC and lots of other dependencies. So that kind of cleans things up for just chat users as well. And with that in mind, it's kind of spread out the release cadence a bit more. But we have voice released now, and we have chat coming at the end of the quarter. So that's great. We've got to this point where it's releasing. It is actually being happening. It's actually live. It's actually being used. It's not just a prototype anymore. And it was now that I was sort of wanted to go back to the teams and say, well, what's actually changed? What reflections, what lessons have you learned along the way? What's different about your day-to-day life now that you're using Kotlin Multiplatform instead of C++ and native stuff? So one point that was raised quite a lot actually was that people felt they needed to keep up to date with Kotlin a lot more. Especially the C++ devs. Well, you know, they're like, the C++ is quite a static situation, or at least at the very least, the release versions are quite slow. And Kotlin is still quite a new evolving language. It's still getting pretty large updates, new features, new changes, and we want to be able to utilize those. So we do need to keep up to date with it. It's quite an important thing to do, and it's a good point. But one thing that everyone was very happy about was that the original pain point of consistency has been completely removed. Whenever there's a new feature, a new API, a new update, it can be written once in multi-platform, and it works everywhere. And the code that's native is very small and really just exposing the rest of it to the user. So because the platform code is just exposing functionality, we've actually had a lot more time as well to improve our API contract. So things should feel much more kind of streamlined and easy to use when you're using the SDK compared to the old SDK. Things should just make a bit more sense as an iOS developer or an Android developer. It should just work quite well. And that's because we have the time now to kind of really work on that API and make sure that it makes sense for developers. Another really great improvement is that everyone knows Kotlin now. Because of that fact, everyone can build a new feature. We don't need 3, maybe 4 people working on one feature to get it implemented across all the SDKs. One person can own a feature and make it happen. This is obviously very different to what it used to be like. And no one person, we're not dependent on any one person either, which is really great. So finally, which is kind of, well, this is kind of something that I could give a whole separate talk on, but another thing that we did do, which some people were very happy about, was we moved to a mono repo for the SDK source code, which from a team's perspective made it much easier to keep everyone synced. Again, you've got one main chunk of code with only little bits across the 3 platforms. So it makes sense for everything to be in one place, but it also means things are much easier to manage. It's much easier to kind of be synchronized across all 3 platforms. It really helps. And again, I could give a whole separate talk on this, but it's a point worth mentioning. And then finally, the most important thing of all, without a doubt, we finally have tests. As you know, developers are our world, and tests are the key to saving developers. Developers appreciate good tested code, and it means that our code is much more bug free. It's much more kind of reliable, and we know it works across all 3 platforms. Without tests, you can't have a reliable library, and this is definitely the thing that I'm particularly passionate about, the fact that we managed to kind of create this environment that's completely testable across all 3 platforms that we support. So when something does change or something new comes in, we, with confidence, can say that it's going to work in this way or whatever it is. So that is how we saved our world. And yeah, I'm really glad for that fact. So that's kind of the end of the story. I will say, if you want to check out the SDKs, you want to check out what we've done in Kotlin, please do check out, scan the QR code. That'll take you to our GitHub community page where you can see the tutorials for using the new SDK in iOS and Android. JavaScript examples coming soon. And you can also sign up for a developer account. And if you use the the coupon code on screen, you'll get 10 euros free credit as well. Send yourself some text messages, voice calls, and all that sort of fun stuff programmatically. But I'll leave it there. Please do, if you want to check out what I'm up to, please do check out my Polywork profile. And also these slides and all the slides from all my talks are available on my GitHub. So thank you very much. And I'll stop there for questions.
Thank you. Thank you, Zach. It was a very interesting talk indeed. And I really like these experience-based talks. You gave a lot of takeaways. I'd like to leave a little bit of time for you listeners to think about questions. So please do write the questions in the chat section. I will then put them on stage. But before that, I actually have a question. So you mentioned that, but it was not the focus of your talk. But actually, I think doing this much rewrite is an interesting topic in and of itself. So, of course, I'm not expecting you to go into elaborate details on that. But what would you say when the developer team faces this decision, whether to refactor in place or rewrite? I think it's a very hard decision, and you have some experience. So, can you share some thoughts about this?
Yeah, I think it's a very difficult point to make, and it can be a very scary point to say, actually, I think we need to rewrite this, because I think for some people it can feel like you're almost admitting defeat. But I think that's where having that kind of experience and knowledge to actually stand up and say, no, we need to do this again from scratch is important. Obviously, there's going to be times where you can just refactor in place, particularly if, for example, it's not the whole thing that's a problem. Like our biggest issue was the fact that all 3 SDKs just continued to drift away from each other. So it was going to be very difficult to bring those back together. But if you had particularly a situation where like maybe just one feature or one element had really drifted, that would be a different scenario that you might be able to just like remove that feature and refactor there. But yeah, it's a tough one. It's very difficult to kind of stand up and kind of almost be brave enough to say, we need to start again. And you're going to have a battle of kind of convincing product managers, convincing, other managers within the company that this is the right thing to do. But there comes a time where it just is. The amount of time we were wasting, trying to make changes in the C++ code base and all these kind of really archaic things that we had to do, the amount of time we've saved now that we've moved over speaks for itself. So yeah, it's a tough one.
Yeah, and I really agree that I think commitment, and also buy-in from different stakeholders and persistence are keys. You also mentioned, the time when you still needed to support or fix bugs in the current implementation while the refactor was ongoing. I think that's a particularly tough things to do, even for developer well-being, so to say. Then maybe better phrasing, motivation. Who gets to work on the shiny new things and who had to go back down the sewers to fix the existing bugs. So yeah,
definitely.
That's always an interesting thing. Yeah. Okay. So we still have one question, but I will put it up. From Brian Michael K. Around when did you make the transition to Kotlin Multiplatform for the SDK?
Sure. So our first beta release was released back at the end of September, and it kind of became stable for the voice component at the end of the year. And then, like I say, the chat component's coming at the end of March this time. So it's still quite early days, and it's still definitely an evolving thing. But I think much earlier, and there were still some technical issues that we were experiencing. It's definitely changed a lot this past year, which is a great thing. It's definitely much more usable now. I don't think I'd have been able to have this same talk 2 years ago. I just don't think that would have been happening. So yeah, it's really great to see the progress that's been made, which also, of course, gives us confidence, because there's obviously a lot of support behind it and a lot of motivation from a lot of people to make this happen. So yeah, definitely.
Cool. And which platform do you think it works the best? I mean, the obvious answer is Android, but I'm curious.
Obviously, yeah, to be honest, yes, Android is the one that makes the most sense straight away. But iOS, I would say, is very quickly behind it, actually. For us personally, with kind of the technologies we're using with like WebRTC and stuff, JavaScript is the one that's kind of lagged behind a little bit. But it's still to a place now that we can comfortably use it, which is obviously great to see.
Okay, cool. So we don't have any more questions, so then I will just thank you again for the amazing talk, and yeah, and see you later. And
yeah, thank you very much.
Thank you for the talk. Yeah.
Cheers. Bye.